Dear friends, welcome to Chemistry Concept Classes. Myself, Manjunatha CR, Assistant Professor, Department of Chemistry, East West College of Engineering, Elanka Campus. As we know, population increases. At the same time, technology also develops to satisfy the needs or demands of heavy population. From the industrial technology, pollution in the environment also increases simultaneously. The pollution may be broadly classified as three types. One is air, next water, also sound pollution. Due to rapid urbanization, the water is polluted more from the industrialization. Household wastewater join with the drainage, then drainage will connected with a river. Hence, water is more polluted in nowadays. To show the extent of pollution present in a water, we can demonstrate or determine by one experiment called as chemical oxygen demand, nothing but COD experiment. Today, I am going to teach you this concept, that is determination of COD of a wastewater sample. See, I will given a first picture, that is it is a pure water that doesn't have any chemical is there. If you go to the second picture, it will contain a colored solution. It colored solution indicates we can easily identify from eye only some chemical is dissolved in that. To go to the third picture, we can see the mud color of the water. Why? Because when the rain will be come and contact to the earth surface, the water becomes color. Why? Because many chemicals is dissolved in that one, and also suspended particles also dissolved in that one. Hence, water becomes a mud color or a brown color. If you see the fourth picture, I will be collected the drainage water. The drainage water is a dark color, dark black color is there, that will contain many various chemicals such as organic, inorganic, and also biological. Nothing but a drainage water. Suppose if you can take from the Kingere drainage, we can come to know that one how much extent of chemical is present. And you can see the fifth picture. The fifth picture and the first picture. The fifth picture, this is the first picture, and fifth picture, most alike, they are colorless. They are colorless, but the fifth picture, I can predict that it won't contain a chemical. I won't say like that. Why? Because it contains most of the chemicals, but they are not develops color. Suppose cadmium, lead. These are heavy dangerous metal ions, but they are not giving any color, but there is a most of the chemical also present. So that's why from the last second picture, third picture, and fourth picture, we can easily say the chemical is present in that one, but fourth picture from the naked eye we can't predict. So to predict the extent of chemical present in the wastewater, we can conduct an experiment called chemical oxygen demand. Next, why we need of COD value? What is the necessity of COD experiment value? Yes, the necessity is COD experiment is to measure the extent of water pollution level, water pollution extent in the given water sample. If you give the water sample, it may be a packaged water sample or a groundwater sample or collected lake water sample, how much chemical is present, we can predict by COD value. Next, we also measure the extent of water pollution in terms of BOD. BOD means biological oxygen demand. Not only COD is used, but also BOD also used to measure the extent of pollution. And but one thing is that BOD is measures the only biologically oxidizable impurity which is present in water. Means it won't recognize the amount of inorganic impurities present in wastewater. So that's why comparatively BOD, COD is more good and convenient to measure the amount of waste. Why? Because it will measures both organic, inorganic, as well as biological oxidizable impurity. So COD is more preferred when compared to BOD. Then what is the unit of COD or BOD? Yes, when come to unit, the unit of COD is or BOD can be measured in terms of milligrams of oxygen overall. Okay, ppm of oxygen is parts per million of oxygen. Next, define COD. Then what is the definition of COD? Then how much amount of oxygen will be consumed required to oxidize both biological and non-biological oxidizable organic and inorganic impurities present in 1 dm cube or nothing but 1 liter or 1000 ml of wastewater using a strong oxidizing agent such as acidified K2Cr2O7. Means they will consume oxygen. How much amount of waste is there, that much amount of mole of oxygen will be required to oxidize all the type of impurities. Means it will require to oxidize organic also, inorganic also, biological also. They will require oxygen. Suppose 150 mole of waste is present, we will provide a 300 mole of oxygen. They will consume 150 mole of oxygen. The amount of oxygen required is exactly equal to the amount of waste is present in the wastewater. Again, you can come to the definition. It is the amount of oxygen required for what purpose? To oxidize the impurities. What type of impurities? It's a biological and non-biological, oxidizable, organic, and also inorganic. All the type of impurities present in 1 dm cube of wastewater is nothing but 1000 ml of wastewater using a strong oxidizing agent such as acidified K2Cr2. In this experiment, we require strong oxidizing agent such as K2Cr2O7 only, but not other mild oxidizing agent. Mild oxidizing agents will not oxidize all the chemicals, so that's why we require what K2Cr2O7 is a preferable. Next is how to determine the COD for a wastewater sample. We require some procedure. What is the procedure we can follow? What is the principle involved in that? We can go to the principle. What's principle behind this means? The principle is involved in method is to treat the given wastewater sample, wastewater sample with dichromate solution for the oxidation of impurities in acidic medium. Why we require acidic medium? You know, you know, we require our representative is a more strong when the student support is there. If there is no student support, then even the representative is weak. Just for an example, our all MPs will be supported to Modi. Modi become very stronger in other country. If they will not support it, Modi is also becomes a zero. Like that, our K2Cr2O7 is a good oxidizing agent in presence of acidic medium only. So that's why H plus medium will be preferable. Acidic medium will be preferable using silver sulfate. What is the role of silver sulfate here? Silver sulfate is acts as a catalyst, and we can also use a mercury sulfate. Why? Because we are taking a wastewater. The wastewater will contain what? Chloride ions, bromide ions. Any halide is there, they combine with the silver, they becomes a silver halide. Nothing but AgCl, AgBr, AgF. These will becomes a curdy white precipitate. Once it forms a precipitate, it won't behave as a catalyst. So to avoid the interference of halide ions or chloride ions, we can use mercury sulfate. To remove the chloride ions, we can utilize the mercury sulfate. Then only it will behave as a Ag2SO4 acts as a what? Good catalyst. Next, what we are going to do here means the unreacted K2Cr2O7 will be estimated. Means unreacted means we supply certain amount of potassium dichromate. Among that, how much waste is there present, that much K2Cr2O7 will be consumed. Suppose if a given wastewater will contain 100 mole of waste is present in the given water sample, but I will provide a K2Cr2O7 200 mole, but how much will be consumed means the consumed is only 100 mole. Why? Because the unreacted we can estimate that the unreacted is 100 we are getting, the provided we already know that one, the provided is 200. If we subtract the remaining, we can come to know that one is consumed. Here what we are going to do means the unreacted potassium dichromate was estimated by titrating against what one standard solution is called ferrous ammonium sulfate, nothing but a what? More salt solution, and with the help of indicators called ferrol, that is nothing but a 110 phenolphthalein sulfate. Next, when come to that one, What happens here means I will return 3CH2O, that is nothing but a aldehyde we have taken. One organic impurity will be taken. You can write waste. Instead of 3CH2O, we can write simply waste water plus we are taken 16H plus. 16H plus means we can provide acidic medium. Acidic medium provides the hydrogen ion and K2Cr2O7 has a containing chromium 6 plus ion. In the presence of acidic medium, chromium plus 6 will undergo reduction to chromium plus 3. And this impurity will undergo oxidation as a carbon dioxide. Means both the reaction reduction chromium 6 plus to chromium 3 plus and this organic impurity into a oxidizes one reduction, one oxidation. This reaction is called redox reaction. See, instead of 3CH2O, you can use any chemical and balance the reaction. Or simply you can write organic waste. 3CH2 is nothing but organic waste. You can take another also, no problem. Next, when come to find out this blank titration without wastewater, sample is carried out. Why? Because by find out in the experiment, we record a blank titration. Blank means without wastewater, means we can take a very pure water, we can take and find out the experiment. If you take a very pure water, 100% pure water, there is no chemical is present, yes, there is no K2Cr2O7 will be consumed. Whatever the donating K2Cr2O7 is unreacted as itself. If you provided 200 moles of K2Cr2O7, then there is no impurity, then there nothing will be consumed. So that's why if you can blank titration is very much necessary. Why? Because we can compare with the blank titration and a back titration. Back is nothing but a wastewater titration. Blank titration means the water which does not contain any impurity. So that's why they will not consume any potassium dichromate ions. See, when come to then what procedure we can follow to estimate the COD? This principle is over. What procedure we can follow? See, procedure is first you can pipette out. You can pipette out a known volume of wastewater, nothing but a 25 cm cube we are taken. You can take 50 also, no problem. 25 cm cube of sample and add 25 cm cube of 25 cm cube of K2Cr2O7. These K2Cr2O7 utilize for the oxidation of waste. This will utilize for the oxidation of wastewater into a 250 cm cube of conical flask. How much waste is present, that much K2Cr2O7 only consumes. Because 25 cm cube of wastewater we have taken, whether it will contain a 5 mole or a 6 mole or 7 mole, we don't know that time. How much we are present is there, we are given mole is K2Cr2O7 is excess when compared to wastewater. So how much waste is present, that much K2Cr2O7 is only consumed, but rest of them is unreacted. You are going to estimate unreacted K2Cr2O7 with a standard reagent called ferrous ammonium sulfate solution or Morse sulfate solution. Dear students, you can see we also added one test tube full of 1:1 sulfuric acid. I already told when our class representative when will be strong means there is student backup support is there. Otherwise, the representative is also not strong. Our Modi is also not strong without MP supports. They will not represent other country. Other country, how they will respect? Our people gives the respect him, then they give the respect. Similarly, K2Cr2O7 is a good oxidizing agent, very strong oxidizing agent. When in the presence of sulfuric acid or in the presence of HCl or in the presence of HNO. So that's why we require a acidic medium. Okay, to strengthen the K2Cr2O7, we added the sulfuric acid. And we added the silver sulfate. Beginning only told, silver sulfate acts as a catalyst. And mercuric sulfate is also added. The mercuric sulfate role is any interfering halide ions are present in the wastewater, they will be grabbed and becomes a mercury chloride. They will not allow to combine with these AgSO4. If they will be combined, AgSO4 becomes a AgCl, that is a silver chloride. That silver chloride becomes a silver mirror. It is present in few experiments. You can go through that one. Next one is what we are going to means you can add a mixture of above mixture means K2Cr2O7 and a wastewater and reflex for an half an hour and cool. You can heat it because at high temperature oxidation will be completely happens. After cooling, you can add 2 drops of indicator. 2 drops of indicator is a remote. Yeah? Ferroin is the indicator. Next one is, when come to that one, what happens is, after adding indicator, you can titrate the above mixture. After refluxing that conical flask, you can titrate against the above mixture, which is the standard solution. I already told, ferrous ammonium sulfate, nothing but a FAS. It is also called as Morse solution. Next, how long you will be titrate? Beginning, once you can add the indicator to the wastewater solution, they will develop a bluish green color. Once you can titrate until complete oxidation of waste. Once complete oxidation of waste, the color of ferrine is a reddish brown. That the appearance of color is reddish brown indicates the reaction is completed. That indicates that one, the amount of unreacted K2CR2 we can consume the FAS. This is the structure of ferrine. Okay, that is called 110. Okay, phenanthroline sulfate. This is the chemical structure. You can go through that in Google. We are getting. Let, how to calculate? Say, assume let volume of FAS consumed for the wastewater for the oxidation in water. How much volume of burette reading will be consumed? YCM cube. This YCM cube is the FAS consumed for what purposes? For the purpose of waste oxidation. For the waste oxidation presented in water. How much volume will be consumed? YCM cube. YCM cube, you can take it and carry out a blank titration. I told that one. Blank titration is nothing but the water, you can take a same 25 ml of water, but that water will not contain any chemicals. Nothing but I taken a double distilled water. In the double distilled water, then you can add a K2CR2O7. K2CR2O7 won't react with a distilled water. Why? Because if there is no waste is present, there is no consumption of K2CR2O7 in the pure water. So that's why if you added K2CR2O7, as it remains, they are unconsumed and unreacted. The unreacted complete, whatever you can add it, you can estimate out with the help of FAS. Hence, here in the blank titration, more K2CR2O7 as remain in the conical flask, but in wastewater, some amount of K2CR2O7 will be utilized. So that's why to neutralize the K2CR2O7 in the blank titration, it consumes more burette reading compared to that of wastewater. Next, when come to how to calculate the COD value, then we require a mathematical formula. See, let us, volume of wastewater sample taken, we know that from the procedure, 25 ml we are taken, and volume of standard FAS consumed in the sample titration. I told sample means wastewater titration. As I told, they will consume YML, means certain ml will be consumed to find out the unreacted K2CR2. Then volume of standard FAS used in blank titration is XML, where X is always higher than Y. Please keep it in mind that X is always higher than Y. Why? Because why we are getting X is more means there is a more unreacted K2CR2O7 present in blank value, means pure water doesn't consume any K2CR2O7. The added K2CR2O7 is completely what we can find out. So that's why X value is higher. ನಾವೇನ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಊಟ ಹೊಟ್ಟೆ ತುಂಬಿರೋನಿಗೆ ಊಟ ಇಟ್ಟಿದೀವಿ ಆತ. Yes. Next one is, what is the normality of FAS solution? We are prepared the standard solution. We know the standard strength, how much we are adding. Strength we know, concentration we know that one. That the concentration is represented as Z. Next is what? Amount of K2CR2O7 consumed in satisfying the COD in terms of FAS solution is equal to X minus YML. X minus YML, I already told, X is higher value in the blank titration value minus back titration value. See, wastewater titer value minus without wastewater. Nothing but WW means without wastewater or distilled water value. Okay, why? Because in the distilled water, there is no K2CR2 will be consumed for the oxidation. Yes, as it is remain, yes, more will be. Next one is, therefore, X minus YCM cube of Z normal of FA solution is equal to 8 into X minus Y into Z milligrams of oxygen. See, how much will consume is 1 cm cube of 1 normal FAS solution consumes 8 milligrams of oxygen for 1 cm cube into 1 cm cube into 1 normal FAS. Similarly, x minus y cm cube, this is a 1 in the place of x minus y cm cube. You can write 8 into x minus y. You can write instead of 1 place x minus y is there. X minus y you can remove, you can insert it, and 1 normal is there. What is the normality we are taken? FES means we are Z normal will taken. It may be same normal or it may be different. So that's why I represented as Z. 8 into x minus y into Z milligrams of oxygen. Next, then what is the 1000? We are measure for 1000 cm cube of the wastewater sample. Then what is the value for what 1000 cm cube? We are estimated for 25 cm cube. The value for this 1000 cm cube in 25 ml is 8 into x minus y into z in the numerator. In the numerator, 1000 you can write, or 1 liter we are taken divided by 25. That we can give the value of milligrams of oxygen per liter. In the above formula is milligrams of oxygen. If you want to calculate per liter, you can substitute into 1000 divided by V. V indicates the volume we are taken. Next one is thank you. Okay, listen. Any doubt is there, you can respond. I will stop here.